My topic today is on the new alternative feedstocks on polyolefins and the impact on the polyolefins, the sustainability. My name is Ali Harlin. I'm research professor at VTT, and this is based on the work we made together with Alexander Rechnenko from our institute as well. So the motivation for the work is that plastics, particularly polyolefins, are very abundant products and part of the essentially of contemporary society, but they have a significant CO2 impact emissions, particularly because of the steam crackers typically. And we are viewing of emerging olefin production technologies, but particularly more the feedstocks available. So green polyolefin, green polyethylene, green ethylene. We are using here a color coding to describe that more in details. The whole presentation is not only the color coding, but in the end we will have a comparison of the different production lines here. So gray and brown. So gray is the contemporary way to produce olefins, ethylene and propylene, and that is typically from the naphtha or natural gas. And there is quite a lot of improvement on those processes and their efficiency over the years, but like there is always the limitation of the fossil raw material base. And then we have the brown lead, which is coming from the coal, and the coal is markedly more complicated raw material, even though it's as well a high in carbon, but like because it's solid material, and that leads that we typically have to go through gasification, and then we are adding oxygen in the system, and then we have to take the oxygen away. So in that way, that is the most concernable alternatives of all the olefin sourcing. Green ethylene, propylene is typically meaning that we are coming from the renewable feedstock. Contemporarily already in a use, not in a large use, but it has been used for some times, is that we have a fermentation from sugars like that of starch or hydrolyzed cellulose or any other possible sources of sugars, and then the formed ethanol is dehydrogenated to ethylene. So it works technically. Of course, there is a concern that when we are fermenting, about half of the mass is already lost there. There are, of course, the other sourcing for biomass to be applied for the ethylene or propylene. It could be utilized like tall oil or some other natural occurring fats or oils, and then hydrogenate them to naphtha and use the same route as with the fossil naphtha, but then it is more like on the, it's a combination of gray and green line. Pink is coming upwards as an its interest, so that typically is dedicated for the recycled plastic. And of course, because the plastic is kind of a solid oil, it's an obvious source for production of monomers again, and but it's a bit more energy consuming than the naphtha cracking, and like there is the question of the collection of the plastic and selection or sorting it, because we don't want to have a high oxygen containing components there, like polyesters or other technical plastics, neither like nylon or so. And then we have the say emerging CCU, carbon capture and utilization route. So the idea is that we could capture the carbon dioxide and then typically utilize quite an extensive amount of hydrogen, which should of course come from the, say, non-emission sources, and through that route we could be even, like if we have emission-free energy available, to be close to zero or even theoretically on the negative side. So when putting all this together, it comes to the conceptual paths for minimum. So of course the recycle of the plastic, reuse of the plastic is even better, so that the shorter the recycling route is, the best. But like the material are typically wearing out, they get dirty, etc., so that there has to be a chemical recycling route. And so we reviewed there the alternative, the pink, so how we could like recycle it. But if the originally the raw material or the carbon is from bio-based sourcing, we are limiting the amount of carbon taken from the ground. So fossil link is like cut totally. And then we have several options. We have biogases, we have a bio-based ethanol or bio-oils, etc. And to make all this to happen, we definitely need somewhere the carbon-free electricity, emission-free electricity. Solar energy, wind energy are of course emission-free, but they are kind of a problematic in a constant availability. So then it comes to the question, where shall we take it if it's not like nuclear or hydropower? And then, of course, this is not coming for free, so that we are expecting some kind of higher production costs. Now I have gathered here all the alternatives in a table, and one thing which you could pay your attention first on is the oxygen carbon ratio of the feedstock. And it seems that the higher the carbon or oxygen carbon ratio is, the lower, which is a little bit surprising, but the lower is the actual carbon dioxide emission. So in that way it says that all the fossil feedstocks will extend the carbon dioxide emission. But when saying so, the removing of oxygen from hydrocarbons is always energy consuming. And if we don't have available of emission-free energy to make that, then the order will be changed even fully, so that it could be even in opposite. In this list, one of the real interesting exception are the, say, bio-based fats and oils. So they are falling to the level where we have a high performance in reducing of the carbon dioxide emission. They are really compatible with an existing processes, so that, but of course the question is the availability. But like this is the comparison where we came in our work with Alexander Reschenko. And highlights on this is that the color coding we gave, but particularly that there are viable ways even in a short-term carbon dioxide emission reductions, and that is coming from that particularly getting rid of the brown coal-based production, and maybe taking steps towards of gas condensates and utilizing the best available technology, BAT practices. But we can also gradually incorporate of bio-based components, so cut the oil dependency, which is a one, and at the same time there is an increasing importance of solving the plastic waste issue, which is more solving the waste issue, but it can have a potential also in a carbon dioxide emission cutting. And finally, and not today, but it's around the corner, that we have to have a technical means to capture the carbon emissions, and then it's coming to this, say, carbon capture and utilization from various sources. Of course, it could be power plants, industrial processes, but particularly would be interesting to have it in the bio processes like pulp industry, where you then really reduce the carbon dioxide emission in an atmosphere. So with these words, I would like to thank you for your interest on our topic, and wish that this has taken us a little bit beyond again on a topic of a more sustainable industry. Thank you.